Hi everyone, so we have come back for this week, week 6. So I wish everyone in a good condition, stay healthy, okay, stay at home, okay, kita jaga kita. Okay, so without wasting any time, so we proceed to our third lab session by this week. So in my screen right now, you see you learn for vehicle dynamics. So we go to under week 6. Okay, so from here you can see we have a suspension system control for our lab session this week. Okay, so for this one, okay, suspension system control. So the synopsis for this lab session is a quarter car model which has been developed using a MATLAB, will be used to reduce the vibration of the vehicle body causing by asymmetric road disturbance via using a PID controller. Okay, so let's move to introduction for the suspension system control. So previously you have learned for the passive suspension, okay, which is the passive suspension system use a conventional damper, okay, to absorb the vibration energy and do not require the extra power. Okay. So this one. So this way we show under this one. Okay. Active suspension or suspension control system. So for the this lab session is actually we talk about like active suspension, whereas active suspension system is capable of producing and improve ride quality, use additional power to provide a response dependent damper. Okay. Oops. So this one is a example of a active suspension system from Audi, which is they call air suspension. They have many type of active suspension, such as air suspension, adaptive air suspension, electromagnetic suspension by Mercedes-Benz, linear electromagnetic motor suspension. So in active suspension system, an actuator or linear motor, hydraulic cylinder, and etc. Is parallel to the suspension system. Okay, is placed between the wheel and the vehicle body. This one vehicle body. So the actuator use the suspension space while pulling down or pushing up the vehicle body in order to suppress its vibration due to the road irregularities, road disturbance or road disturbance. Okay, so active suspension also control the vertical movement of vehicle, which is relative to vehicle body implementing or an onboard system that sense the forces applied to the wheel, and thus the system will adjust the various mechanical connection to maintain the chassis level of the vehicle body. So this kind of system or device is actually very high cost and high maintenance. So it will restrain the automotive to produce into the market, and the installation of the active suspension system into the existing vehicle may require a major modification. So this one is an example, another example of active suspension. So I will show you the simulation in lab, one actual lab here. So you can watch this video for a moment. So this video is try to simulate the active suspension system using the LQR. Okay. LQR. So here you can see the suspension model. Okay, this one is a payload, which is a car body. Okay, so this one is suspension spring. Okay, so this one is a car frame. Here, just now. So at the bottom, we see the road disturbance. We put an input as a road disturbance. Okay. This one is for the normal suspension system. You can see here the payload also moving together with your road disturbance. Okay, so we put a system in order to control our suspension. So this one, in this video, they using LQR controlling. But then in our lab session, we use a PID controlling. So if you compare from here, there is a different movement here. For the right side, the car body is not moved. Okay, so the only movement mostly covered under unsprung mesh. So for the sprung mesh here, it will not disturb any. Okay. So just now you already seen the actual simulation test in the lab. So I want you to watch the real application in the automotive sector. So you can see from here. So this video showing a new Audi A8. So forget the bumpy road. So you see from here, they put a controller on the right side and then controller on the left side. So the new technology they're using the front camera to detect some bumpy road and then send the signal into this controller. At the back also they put the controller. So roll reduction when cornering, and they use the active suspension. So the camera detect the irregularities on the road surface and then provide the signal into our controller here. If you see here, only the unsprung mesh move up and down. The sprung mesh don't move. So the pitch reduction also reduced during the braking, or we are accelerating our car. Dip on all the vehicle side during a pending side crash. Alright, so you just see the application on the real life for the active suspension system. Okay, so we go back into our lab session. So next one, in this lab session, I will introduce you the PID controller. So this PID controller is to calculate an error value as a difference between a desired set point and measure process variable and apply a correction based on proportional, integral, and derivative terms, which is we call it PID. So the P stands for proportional, I stand for integral, and D stand for derivative. So basically the diagram you will look like this. Okay. So the PID controller, the most used feedback control design. Okay, PID is a short form, as I mentioned just now, short form for proportional, integral, and derivative. Show the three terms of operating on the error signal, okay, error signal to produce a control. This one error value, and then to produce a control signal here. So the desired closed loop, so this one desired closed loop from the process, we desire closed loop dynamic can be obtained by adjusting the three parameters Kp, Ki, and also the Kd. So inside the lab session, we have the value for the P, I, and D. So this value often iteratively tuning and without specific knowledge of a plant model. So usually the stability can be obtained using only the proportional term. Okay, the integral term permits the rejection of the step disturbance. And last one, the derivative term provide a damping or shaping of a response. Okay, so let's go to our lab here. Okay, so you see here, same as I showed you just now. So basically we use the previous model of passive suspension, and then we try to convert into active suspension MATLAB simulink. Okay, so the value as I mentioned just now, the proportional Kp, K3, Kp, Ki, Kp, Ki, and also Kd. Okay, so the result for the first function, we use a step function. Okay, so after you can run for the step function, we move for sine wave function, and then last one repeating sequence. And then from the output of the MATLAB, you need to plot the graph as below, as I mentioned in your in this lab. Okay, so we go to our previous lab, this one. So you need to open your previous MATLAB. So from here we try to convert into active suspension.